Lab 5, Faraday's Law. In this experiment, we will be using Faraday's law to analyze the forces of a falling magnet inside of an aluminum tube. Some basic principles that we will be using is Faraday's law, which is the change in flux over time, which is equal to I times R, which is also our EMF, and the Biot-Savart law, which is our magnetic force, is equal to our induced current I times L times B times sine of theta. We'll also be using Newton's second law, which is our F net is equal to mass times acceleration, which is also equal to the sum of the forces, and Newton's third law, stating that for every action there is an equal and opposite reaction, which is equal magnitude but different signs. Our experiment and results. Essentially, like as stated before, we just dropped the magnet down an aluminum tube and recorded the times. So for this, we did 5 trials. We will also be using GlowScript to create a simulation. For our trial times, we have those listed below, and we also have our dimensions of our foil. We have that our average time is 1.61 seconds. For the GlowScript code, we begin by calculating the magnetic field as shown in the first one. Then we calculate the change in flux, magnetic flux. We also then use these two to calculate our F net, which will be our magnetic force plus our gravitational force. And by doing this, we can also calculate the change in velocity and position. For our results, I have 3 different snapshots of the motion. First, we begin with the velocity decreasing, and once it enters the magnet enters the tube, the velocity becomes constant, so we have 0 acceleration. Our ending time is 1.672 seconds, which does not differ much from our expected value. Questions to consider. What if the resistivity of the conductor were reduced close to 0? The magnetic force increases as the number becomes greater when multiplying the force of gravity. We're multiplying, and the force of gravity will be much less than the magnetic force, causing it to fall slower. This is the definition for the Biot-Savart law. And what if the holes were cut into the tube? The EMF will decrease, causing the force of gravity to be stronger than the magnetic force, causing it to fall faster. We can also simulate the first question through our GlowScript code, which I did to confirm